Okay, and it looks like we are live. Good morning, good afternoon, good evening, everyone, and welcome to SETI Live, a special 2022 edition. My name is Simon Steele. I'm the Senior Director of Education and Outreach at the SETI Institute, and I'm joined today by my colleague, Dr. Franck Marchis, who's the Senior Planetary Astronomer at the SETI Institute. So, hi, Franck, how are you doing, and how has 2022 started off for you?
I'm good. I'm in San Francisco. It's been very hectic already. I have the
Mm-hmm.
feeling we have like 2 years in the first 15 days, I would say. What
Yes.
about you?
Good, good. It seems as though life down on Earth is very similar to this time last year, 2021, where the world is going through its usual pains. But up in space, things are changing and getting very, very exciting. So we're going to do a review of what to look forward to in 2022. And we would invite your comments, as always. Please do send in to the chat where you're tuning in from. And also, we'll be fielding your questions as we move on through this discussion today. So, Franck, let's talk about what's going to happen in 2022. There's a lot of very exciting things going on up in space, and we'll be launching up into space. And we decided that we'd actually work our way out through the solar system, which seems like a nice way to do this. But want to start close to home, and of course the big the big elephant in space, rather than the elephant in the room, fortunately it's in space now and not in the room, is JWST. And I'm going to bring up and share a time map of where this space telescope is now. And Franck, give us a little bit of update on the James Webb Space Telescope and what's happening.
So the James Webb Space Telescope is a flagship mission in astronomy, basically. It's the largest telescope built in space that will be in space. It's a 6-meter aperture telescope. It was launched in December by Ariane 5 of last year and is now en route to the L2 Lagrange point. And while going there, he also basically unfolded. And I will say that over the past 2 weeks, I've been looking at the progress of JWST, and I'm impressed to see how well everything is going. I mean, the sunshield deployed properly, the secondary as well, and now the primary are completely open. And they are going to start cooling down the spacecraft, the telescope, because it's a telescope dedicated to observation in the mid-infrared. And then going to do the complicated phase, which is the commissioning.
Right, and of course, because this is such a big telescope, to fit it in the rocket, you need to fold it up, and the unfolding was the dramatic part, wasn't it? Yeah. Once you're in space, you got to unfold this huge mirror. It's a segmented mirror, so it could be folded up, but like a sort of anti-origami, where it's sort of opening flat. And all of those maneuvers and unfoldings seem to have happened flawlessly, which is quite amazing, isn't it? I mean, it's not amazing that it's happened flawlessly, but it's amazing that we're at this stage now.
It was stressful for the community of astronomers that we launched a $10 billion telescope in an Ariane 5, and we will try to unfold it in space, knowing that there is no way to fix it if it didn't work. So, So we observe it, in fact, using our network at the SETI Institute. We have more than 100 people who observe it using the unistellar telescope, and they saw the telescope drifting away, getting fainter and fainter, and then getting brighter because they opened the sun shield. So that was, it's been very interesting to observe it from the ground as well.
Yeah. And as you say, there's a sun shield there. It's the size of a tennis court, I believe, and that is really to protect the optics and the infrared detectors from hot objects, and that includes the Earth and the Moon and anything that has a large radiant surface. An interest in this diagram, which is taken from the JWST website, it shows the difference in temperature between the hot side of the telescope and the cold side of the telescope. This is data from this morning. The hot side is sitting around 11 degrees C, which is a nice temperature, and the cold side is down at -200. So the sun shield is doing its bit and keeping the instrumentation and the telescope itself, the mirrors, nice and cold. And it's going to continue to cool down, isn't it, until you're at a position where you can start taking the first images. And that's probably going to happen around March, when it would see first light. Could you define what first light is for a telescope?
Yeah, for a telescope, a first light is basically the first time the telescope will capture photons coming from a target, a star. We don't know what will be the first target of JWST. In this case, we are going to have multiple first light because there is multiple instruments on board JWST. I don't remember which one will be the first one, but it's a mystery still what will be the first light of this telescope.
That's right. It's a big secret, and I know that I've spoken to somebody who is on the committee, and of course they won't say anything at all, despite being bribed.
Can we make assumption? Can we bet?
That's a very, very good question. I think, well, what I'm going to do actually is going to show, going back in time a little bit, to the first light image of the Hubble Space Telescope, because there's always a comparison. And what's interesting about this is it's not a particularly beautiful image. It's a beautiful astronomical image, but it's not colorful in any way. This is from 1990, and this is the first light image from Hubble. And Franck, what are we looking at here? Stars.
Boring stars. So on the right, you see the first light of Hubble Space Telescope with the wide field camera. And on the left is a comparison of what you could see using the Las Campanas, I think it's a 1.5 meter telescope at the time. And you can see that the Hubble Space Telescope seems to be sharper in terms of the quality of the image. But the story here, I don't know if you know that, but in fact, the first light of Hubble Space Telescope was supposed to be a very impressive object, something like the Orion Nebula or something like that. But when they open the telescope and they turn it on, basically, and they collect the first photons, they quickly noticed there was something wrong with it. The image quality was not as good as expected. So they decided not to reveal the true first light and to only reveal this first light, which is a field of a few stars instead of the beautiful object that we wanted to. And the reason, you probably know why the first light was not as good, right?
Mm-hmm. So
there was some issue with the polishing of the mirror. Basically.
There's the surface, the misalignment, or sort of the testing of the mirror curvature was in error. So there needed to be a corrective.
So that's the reason we do commissioning.
Yeah. Yes.
Commissioning is basically to make sure that the telescope works as expected. Each parameters of the instruments are being tested. Make sure that we can collect the data, process the data. So the commissioning is a very important phase in the life of a space telescope specifically, or any telescope, because that's the moment where you validate whether or not the telescope will be able to achieve the scientific goals and objectives that it was designed for.
So these first calibration images, these are the first light images, will probably be March, and then in May will be the first press image, if you like, and I'm just going to show, this is a Hubble Space Telescope image, but let's bring up another. Whoops, previous slide. That's not a Hubble Space Telescope image. That is a Hubble Space Telescope image.
Yeah, and this was taken after the correction.
This is a very recent one of a galaxy called Messier 100, which was one of the first galaxies imaged by Hubble, and it just shows you the absolutely glorious image you get of this spiral galaxy. And I would like, personally, because I like galaxies, I would like a galaxy to be one of the first light images from JWST. Now, JWST is a bigger telescope. We should probably move on to other things of 2022, but JWST is a bigger telescope, and yet it's observing at longer wavelengths. So the resolution the telescope is going to be very similar to Hubble, isn't it? Except you are observing in infrared wavelengths.
Yes, that's correct. There is also one instrument that will observe in the visible. So we are going to get pretty picture in visible, but it's not the same, it's not the main goal of JWST. JWST is not the successor of Hubble. JWST is the successor of Spitzer telescope, which was a small mid-infrared telescope. So so you bet that the first light will be a galaxy. I can bet that it will be a nebula, a famous one.
Okay.
Orion or something like this. Let's see.
Let's see. We'll put some money. We'll put some maybe some euros or pound sterling or dollars on that, and probably, but not much. So JWST is obviously that's the huge, potentially huge news item of 2022. But there's lots of other stuff happening. Let's turn maybe to let's go through the solar system. So anything happening on Mercury or Venus this year, Franck? Do we as we start off with the inner solar system?
No, in Mercury there will be a flyby by the Pepe Colombo ESA mission, which is a mission which orbits in the inner part of the solar system at the moment, and will fly by for the second time Mercury. So take some very close snapshot of the planet. And I think in a year and a half, it will basically be in orbit around the planet. So there's not much for Mercury. And for Venus, frankly, Venus is being right now observed by several spacecraft, but there is nothing specific. Nothing new is coming to Venus for the moment.
Right. And the flyby of Mercury is to actually take some of its speed out, isn't it? Because you need to slow these things down as they fall towards the sun. You build up a lot of momentum, and you need to sort of strip that away by doing these flybys before you can actually get into orbit. Yeah, so that's going to be exciting when that actually ends up in orbit. Okay, moving out to the Earth, planet number 3, and of course the Moon. We've got some stuff happening on the Moon. There's always sort of the Artemis mission and things potentially going to the Moon. What's actually going to happen in 2022 with the Moon?
A lot's going to happen. I mean, I have to list and to look carefully everything. I think I'm probably going to miss some. Okay. The main part in the US, it's of course the first launch of the Artemis program mission. So this is Artemis 1 that will be launched by a Space Launch System rocket, which is a famous rocket which has been in development for decades now. And on board this rocket, there will be an Orion capsule at the demonstrator. So this mission is really truly to demonstrate the capability of SLS to go back to the Moon, because the goal of Artemis is to bring human on the Moon again, to land human on the Moon in 2024, if I remember the date properly. Right. So this is going to be a demonstrator. The capsule will be ejected by the rocket and do this kind of long retrograde orbit around the Moon. So to see if everything, all the system works great. So that's the first part in the US for NASA. But then there is also the CLIPS program. So those are the commercial payload service program. And this is a private, this is basically mission funded by NASA. It's $2.6 billion for this program. And those are private companies that are going to land on the surface of the Moon. So there is a lot of them. I didn't have the complete list, but this year we're going to have a lander called from a company called Intuitive Machines. It's called Nova C lander. Nova C is going to be launched in April. And then there is a second one from the same company that will hopefully land on the surface of the Moon on the south pole of the Moon in December. And we also have the Astrobotics spacecraft. There will be a lander called the Peregrine Mission 1, which will land on the surface of the Moon in mid-2022. So there's a lot of them. And something that's very important here is that NASA is paying those private companies to land on the moon. We can expect that several of them will fail. It's part of the game, I would say. It's a risky mission. It's to give the opportunity to private company to develop the technology to land on the moon. NASA incentive here is to basically lower the cost of landing on the moon. So in the future, we can go there and build a human base by using this private industry. So it's to build an ecosystem of private industry companies to be able to go on the moon.
And the ultimate step then is to go to Mars, because it's easier to launch a mission to Mars from the moon. The gravity is less than to launch it from the Earth. And so that's the ultimate goal. Thank you everyone for tuning in. We've got a few countries here, Finland, England, New York. Thank you, Ron, for sending some stars. Myrtle Beach, Lancaster, Ohio, Canada, another Manchester, UK, somewhere in the Midwest. Who else have we got? Lindsay sent some stars as well. Thank you so much. And Uruguay as well. Thank you all for tuning in here. That's wonderful.
So to finish with the moon, I want to mention that I mentioned the American side here, but there is a lot of other countries which are going back to the moon or going to the moon for the first time. ISRO, the Indian Space Agency, is going to launch an uncrewed mission called Gaganyaan. I'm sorry for the pronunciation, because they have the ambition to also land human on the moon in 2025. So that's kind of a demonstrator as well. Russia reactivated a program. You probably know the Luna program, which was a program from the 60s and 70s, right?
Yes, a long time ago. I remember. Yes.
And now Russia is landing. Is going to plan to land Luna 25, so it's the 25th Luna, and this is a lander that it's supposed to reach the lunar solar pole. And once again, this is to find water ice over there and to investigate whether or not we can put a permanent base on the moon there. And more smaller countries, Korea is going to the moon with a technology demonstrator mission. United Arab Emirates is also planning to go to the moon and take on board a Japanese macro rover, a very small rover called Akuto R, and that will inspect the surface of the moon. I mean, there will be a lot. Moon's gonna be like
it's gonna be a bit crowded up there, isn't it? Yes. Yeah, it's gonna be rush hour. Going to the South Pole and the moon, we got these regions called permanently shadowed regions, which are craters at the poles, which never get direct sunlight, and so you have these areas that could have very large reservoirs of water, and that's good because you don't want to have to start carrying water up to the moon. Water is a very heavy substance when you've got a lot of it, and if you can get it when you get there and you don't have to lug it around, then that's going to be a game changer. So that's going to be very exciting. Good. No, that's moon. Lots of stuff happening on the moon. Let's move out to planet number 4. What's happening on Mars? I mean, there's lots of stuff rolling around Mars still at the moment, which is wonderful.
Yes.
Any new additions to the Mars family?
Well, there is something that is going to be launched to reach Mars. That's the Exomars Mission. The launch is scheduled in, when is the schedule? December 2022. So at the end of this year, right?
This up, yeah. There we go. This is the.
So that's what's it? Yeah,
September 22 launch window until October.
So this is a mission between ESA and Roscosmos, the Russian space agency. What's really interests me in this mission is that we are also going to have a lander, a rover, in fact, and of course, I just forgot the name of the rover.
It's the Rosalind Franklin, named after a British microbiologist who was instrumental in the discovery of the structure of the double helix. So it's a wonderful tribute to her as a scientist, and as a search for life, of course, it's a very fitting name.
Yeah, definitely, because that's the main goal of this mission, is to provide clue that there were some kind of ancient life on Mars. this rover will be able to dig very deep into the surface of Mars to collect sample. I think it's 3 or 4 meters if it's possible. So it's gonna be, this is an interesting mission. It's been delayed because the previous lander, European lander, did not make it to Mars. It's a very difficult thing to land something on Mars, apparently. So everything, kind of the entire mission has been reassessed and so on. So we hope that this mission will succeed. We will not know that in 2022. We'll know that in 2023 because that's the date the mission will reach Oxyaplanum on June 10th, 2023.
Right, and look at old floodplains or potentially old floodplains of Mars, yeah. And it's not as big as, say, the Perseverance rover. I think it's about a third of the size of the current NASA rovers. So, you know, the NASA machines are still the SUVs on the surface of Mars, and this is a little Mini Cooper. But yeah,
Mini Cooper, right? Yeah. I knew you would use that as an example. Or a Renault 5.
Yes.
Anyway.
So yeah, so that's very exciting. It'd be nice to get that rover, and it's a great collaboration, and getting Russia, active again in space exploration, which is something they do well, is good. Okay, that sounds great. Let's see who else we've got tuning in here from Argentina, from Birmingham in England. Thank you, Paul, for sending stars from Calgary. Michigan and California. And if you have any questions for Franck or I, please do pop them in the chat, and we'll try and answer them. Let's move out to Jupiter. Or did you want to do? You want to do? Oh, are there asteroids? I forgot. I didn't. Yes. No. I'm kidding. Let's do asteroids, because I know some people here like asteroids. And I actually want to. I know you maybe don't want to bring this up, but we have a little visitor coming in very soon. And I'd like you to say a little bit about that, because there may well be questions. And this is our visitor on the 18th of January, 1994 PC1, which is a sort of 1-ish kilometer near-Earth asteroid that's absolutely not going to hit us. So any comments on this one, Franck? Because it's a
it's 1994 PC1. It's been discovered quite a long time. It's been follow up for 40 years. We have 40 years of data on this orbit. So we know it's not going to crash on our planet. What is interesting here is that it's going to pass very close to us, 5 to 6 times the Earth-Moon distance. And the closer is an asteroid, the brighter. And of course, if you want to get information about the asteroid, such as its composition, shape, and size, that's the perfect time to observe it. So this is a large one. 1 kilometer in the NEA population is typically the largest NEAs. Most NEAs are very small. So that's the reason we are following up this one. We observed it, in fact, with the Unistellar network as well a few days ago, and we are going to have a campaign in January 17, 18, 19 to observe it while it's flybying our planet, to get shape model as well, and and also get a fun observation, because we see the dot moving in the field of view. I mean, it's always fascinating me to see.
Now, we're not going to have any asteroids crashing into us, but we are going to be crashing into asteroids, aren't we? Yes. Because we have the DART mission, which launched and
last year. So DART is a NASA planetary defense mission. It's composed of a spacecraft and a CubeSat, in fact, and it's not gonna impact the asteroid itself. It's going to impact the moon of the asteroid, that is called here Didymos B. It has a new name called Dimorphos. That's a real name. So it's a 100 meters diameter body. The primary is 300, 400 meters, to give you an idea. The goal here is to test a technology to be able to divert asteroid called kinetic impactor, which is basically what it just meant, to send a spacecraft high velocity on an asteroid and see the effect of this impact to deflect the asteroid. So in this case, we're deflecting the moon. So what we expect to see is a slight change of the orbit of the moon due to the energy brought by the spacecraft during the impact. So that's going to be very interesting. I mean, it's great we are testing technology to divert asteroids because we may need that in the future. We don't know yet. We know only the last number was 30% of the 100-meter size 100-meter size asteroids. I need to check this number, but we still don't know a lot of those asteroids. So we know that we are going to find asteroids of the size of 100 meters in the future, and maybe some of them could impact Earth, so could potentially impact Earth in the future. So we need to know how to divert them to save our civilization.
And a small diversion early on is easier than a big diversion later on. So tracking these as early as possible is very, very important. And then you can literally make an impact on any sort of hazardous objects. So there's the stick with the asteroid belt, and there's the Psyche mission, isn't there?
Yes,
coming up. And let me just. And this is a different mission because this is going to be looking at. Oops, I'm trying to
Asteroid
multitask
Psyche.
here. Asteroid Psyche, which is an iron meteorite, iron asteroid rather.
Yeah.
A very high density object. First of all, how do we know that it's made of iron? You know, what's so it's just a I mean, this is an artist's impression. It doesn't look like this because it's just a speck on a in a telescope display. But how do we know what that is made of?
There's two ways to do that. One is to measure the density of the asteroid. So for this, you need to be able to know its shape accurately and its mass. So we have a paper published last year where we basically derived the shape of Psyche from combining ground-based observations with the VLT and other telescopes. And we derive a density which is between 3 to 4 grams cc. So slightly less than what we expected. And there is also another ways to look at the radar echo, because you can also get information about the amount of metal from the radar echo. And it's kind of clear that there is a lot of metal in this 220-kilometer asteroid, but we don't really know if it's truly a purely metallic iron body. I don't think so, in fact. Or it's kind of a mixture of iron and rock. And in this case, I will say is equivalent to what we call mesozoic meteorites. It's kind of a very interesting meteorite, quite rare, for which you have a mixture of iron and rock to combine together. So I love this mission. It's gonna be cool to see the first picture of an iron world.
How close are you going to get?
It's gonna be orbiting it, so it's gonna be as close as possible, and probably if there is no water on it, they will probably land the spacecraft on the surface. That's generally what we do when you explore an asteroid. If there is no water and you're not limited by the planetary protection rules, simply land the spacecraft directly on the surface. They have done that for Eros in the 90s, and I think they will probably do that for Psyche. They did not do that, for instance, for Ceres with Dawn. Dawn will orbit around Ceres forever, probably, because they didn't want to land the spacecraft on the surface of Ceres. As soon we discovered there was some potential water or even ocean beneath the surface.
Yeah, and that's as you say, an important planetary protection consideration. If you have water, then however rare the chance or unlikely the chance, there is a chance that there is a potential biology or prebiotic environment there. And so that makes sending missions to these types of bodies much more important to take into consideration, that you don't want this cross-contamination, bring bugs from Earth and dump them on that world, or if you're doing a sample return, bring things back to Earth that may be a problem. And so that is a very, very big consideration for NASA and all space agencies, the subject of planetary protection, which is transporting microbes, as opposed to planetary defense, which is protecting from very large lumps of rock, which is what we were talking about earlier.
It is one thing I discovered preparing this program is that Psyche will also have on board secondary payloads, small CubeSat, something like that, called Janus. And they will release Janus when the spacecraft will fly by binary asteroids with a beautiful name, 1996 FG3 and 1991 VH, which are, I think, main belt and NEAs. I would check that. But those are binary asteroids. As you probably know, I like binary asteroids. So when I found out this, I was excited. So there will be, we're going to have probably pictures of binary asteroid while Psyche fly through the solar system en route to Psyche, the asteroid.
Wow. Okay. That seems the way to do it. Actually, just drop stuff off as you fly around. Yes, just cheaper. I'm going to do one question before we move on to a world that does need quite important planetary protection considerations, which are the ocean worlds of Jupiter. There's a question about mining asteroids. I mean, how reasonable is that as a prospect? I know we've talked about the commercialization of space, and is this something that is this next decade? Is this within 100 years? Is it just science fiction?
It's not just science fiction, because we will need that. There is no way we can explore our solar system without mining asteroids, because asteroids are the advantage of bringing material and not having such a strong gravity. So it's easier to extract the material and use it. But it's also complicated because you're working in this kind of microgravity or zero gravity environment. And we don't really know how to mine in this type of condition. So we are truly learning this at the moment. There was some company that were created in 10 years ago, even less, who were basically had as a goal to inspect asteroids and then probably later on go to mine them. We're still in the phase where we are trying to know what is the composition of an asteroid. But when I say composition, is not only the color and if it's made of iron or nickel or stuff like that. I'm talking about real composition. Like when you take a rock, the density of the rock is great, but it's also the way the rock is made, inclusion of material. If there is iron in this rock, where is the iron? How you can extract it? Those are very complicated technology that we don't know yet how to use them in microgravity. And I think we need to learn to do that. So we are exploring asteroid at the moment. That's why we have those missions, Lucy and those microsatellites. The Emirates announced recently that they will also launch mission to explore asteroid the next 5 years. We're going to see more and more of those, and then we are going to develop the technology to do that. But it's going to be probably a private industry that will do this, because there is some monetary interest to do that and incentive as well. But we need support from NASA to do this and some other space agencies.
Yeah, because that's a big. I mean, not only getting there, then there's it's as much robotics and AI to interpret the situation, when you're there, as just sort of astronautics. Yeah, it's going to be exciting. Let's move out to the outer solar system, unless you want to talk a little bit more about asteroids. Not that I'm rushing you through the asteroid belt. We do have a mission already doing amazing work around Jupiter, and that's the Juno spacecraft. And I'm just going to show a picture, because Juno, it's mainly exploring the planet Jupiter itself, but later on this year, it's going to do a close flyby of the moon Europa, which is one of the 4 Galilean moons of Jupiter. And we're going to really go close up at this, what is being called an ocean world, because although we have, as you can see, a very crusty, icy surface, it's quite likely that below this crust is a liquid, salty ocean. Juno's doing a flyby. It's not doing a lander, but this is going to be a very interesting to get a very high resolution image of this moon.
Yeah, but Juno doesn't have a very good imager, unfortunately. You know, it's just a webcam. I mean, when I say that, it's just a webcam in space. So we are going to get some pictures, but they're not going to be like extremely good quality picture that we had with the previous missions, such as Galileo spacecraft. However, because Juno will fly by very close to the surface, you will also detect the magnetosphere of Jupiter and Europa and the perturbations. So that may be a way to finally confirm the existence of this ocean by measuring simply the profile of the magnetosphere. We will know that. Or we will be extremely lucky, and I will love that, in fact. And while the spacecraft fly by Europa, we may be able to look at the area observed by Hubble space telescopes and see those kind of geyser-like activity that's been kind of inferred from data from this Hubble space telescopes, and maybe finally see them in action, because we have not yet seen those geysers in action. So if they're there, we'll be able to see them.
And this is as you can see from this image of there are cracks in the surface of the ice, and that's a possibility of where this material that's under pressure will push through weak points and will break through to the surface. And this has been observed on Enceladus, which is another ocean moon around Saturn, and has been observed from a distance from Hubble on Europa. So that's going to be very exciting. And of course, we do have a NASA mission called Europa Clipper that will have a high resolution camera that is returning specifically to Europa, and that launch date I think is 2024.
Yeah.
So that's very exciting. Nevertheless, the European Space Agency is launching JUICE, which is going to be very exciting. And JUICE is a mission and stands for Jupiter Icy Moons Explorer, which is wonderful. I haven't seen their logo yet, or their badge. I think that's going to be very exciting, and lots of marketing opportunities. And JUICE is going to be launched in June, I believe.
Yeah, June, that's correct.
Yeah. And let me bring up an artist's impression of JUICE here. And this is a composite. This is lots of nice images from, but there's a composite image and, of course, an artist's impression of the spacecraft as it heads over to explore the icy moons, which are 3 of the 4 Galilean moons have potentially oceans underneath them, don't they?
Yes, Ganymede, Callisto, and Europa.
Yeah.
And we did not see this ocean, but we detected through the magnetosphere, as I mentioned. And what is interesting here is that we are going to have a mission with very good cameras on board. So we'll also be able to compare the Galileo data to this new data and see probably some change on the surface. I'm betting we are going to see that, in fact. Some may change on the surface of Europa due to the tectonic activity, or change on the surface due to the geyser-like activity that I mentioned. So that's one of the reasons it's great we're going back finally to explore the Jovian system, because we are going to be able to see the changes since the last observation we got from Galileo spacecraft, which was, I think, in 2001. It's been, it's
been a while.
Unbelievable.
Yeah. So that's very exciting. Of course, that's a launch to Jupiter, and so the results of that, we're a few years down the line. Franck and I will be back. I'll be grayer, and Franck will be gray when we review the results from the JUICE mission. But getting close-ups of these moons, which are now sort of prototypes for the types of worlds maybe that we're detecting, sort of exoplanet worlds that may well be more similar to these icy moons than Earth when we're looking for locations of life in the universe.
Yeah, I just realized that the Jupiter orbit insertion is 2030.
Okay. Wow. Yeah, I can't wait. Yeah, it's good. Just around the corner. That's a review of the missions that are coming up, both arriving and launching. Franck, what else is going to
talk
excite
about
you?
the fact that we don't have mission for Saturn, Uranus.
It's sad, I know, and there's a situation here that the outer, what are called the ice giants, Uranus and Neptune, really are way overdue a visit.
Yeah.
And although it's great that we got a couple of Venus missions coming up, I think somebody needs to get something launched to the outer solar system very soon.
Yeah, because we do know now, looking at exoplanets, that there is probably a lot of exoplanets like Uranus and Neptune. So truly understanding how those planets evolve and were formed is something that we don't yet, we have done yet a clear understanding of this. Mm-hmm. So if you want to understand exoplanets, we need to understand the planets in our solar system. So I'm really advocating as well for having missions very soon to explore these icy planets. And hopefully the next selection of NASA or ESA will be dedicated to that. But in the meantime, we should mention that in 5 years, we're going to probably have the European Extremely Large Telescope and the TMT maybe and others. And those large telescopes equipped with adaptive optic systems will be able to get some very good picture and data of those planets. So get more information about them. So while there is no spacecraft on the ground, we are developing technology that gets better over time, with larger aperture telescope, capable of observing a shorter wavelength. So we are getting better data as well for those planets.
We almost discussed a large new telescope, but we've realized that the first light for the Vera Rubin is 2023 now. So we can save that for this time next year. But that's going to be a very exciting prospect. What's happening in the world of SETI? We of course, at the SETI Institute have our own radio telescope facility up in Northern California called the Allen Telescope Array, and it's starting to make observations and detected an FRB, a fast radio burst, last year. And so that's very, very exciting developments at that end.
Yeah, and then we also have Laser SETI, which is growing. I mean, we have now 2 stations, one in California, one in Hawaii. I don't remember the next when will be installed the third one, but operation of Laser SETI will start as well. So maybe we should remind that Laser SETI is basically a wide field camera that observes continuously the sky in the hope of detecting laser beam coming from advanced extraterrestrial civilization.
Right, and this isn't necessarily an extraterrestrial war with lasers. This is a type of pulse laser that maybe is driving light sails of spacecraft, and that's a technology I know that is being investigated for humans to do this, to power these micro satellites, spacecraft out to about 1/5 of the speed of light to move into interstellar space. And if another civilization is doing that and we're on the line of sight, then these are things that could possibly be detected. So that's pretty cool as well.
And we are planning to continue developing the unistellar network with SETI Institute. And this will basically also be able to follow this kind of laser signal if we detect one this year.
Yeah, so let's see if we've got any questions. I think we're running over time a little bit, but this is a fascinating conversation. There's so much happening here. There's one question about, is it true that there is a gold asteroid?
I don't know about that.
Yeah, no, well, we wouldn't tell anyone even if we knew about it, would we?
Case.
Yeah.
So, something very important. Once my kids asked me this question, and I explained to them, by the law of economics, if we find a gold asteroid and we bring on Earth, and is, let's say, 100 or 200 kilometers in diameter and made of gold, then the value of gold will drop significantly. So the asteroid you brought will have 0 value.
So the idea is to not mine a gold asteroid.
Or to mine it, but slowly.
Yes, yeah. I think we should wrap up here. Thank you for everyone tuning in.